Hey folks, so in today's lesson we are going to be talking about centroids, circumcenters, and orthocenters of triangle. In this lesson we are going to be talking about how to actually find the centroid and the circumcenter. We're just going to briefly talk about what the orthocenter is, but you do not need to know how to find it. So the centroid is the point of intersection of our three medians, and I have drawn an example here of the three medians of triangle ABC. We recall that the median is the line that connects one vertex to the midpoint of the opposite side. So for example, I have vertex A, which is connected to the midpoint between B, C. I've done the exact same thing for vertex B, and the exact same thing for vertex C, and we can see we have a midpoint, we have a centroid located right in the middle there. That is our point of intersection. This is also referred to as the balance point, and you'll kind of understand why in this example. A triangular table with only one leg can be drawn on a grid with vertices A, -3, 4, B, 6, 3, and C, 2, -5. Determine where the one leg should be placed so that the table is balanced. So you can imagine it's a triangular table with one peg sticking out of the bottom, and it needs to be perfectly in the center so that it is balanced. That's why this is called the balance point. There is a long way of doing this, and we are going to go through all of the steps together. Essentially, we need to find the point of intersection of two of our medians. If we find that point of intersection, we know it's going to be the exact same point for the third median, so that's what we need to find, the point of intersection of two medians. Well, in order to find the point of intersection of the two medians, we need to find the equations of the two medians. In order to find the equations of the two medians, we need to have the midpoints for both of those sides. So I also need to find two midpoints before we can even proceed. The only information I have are the coordinates of my vertices. However, I can use the midpoint formula to find the midpoint. I can then use my knowledge on finding the equation of a line between 2 points in order to find that equation. And finally, I can use one equation and the other equation to find the middle, to find the centroid, and then the problem will be done. So a lot of kind of backwards thinking, backward planning here in order to figure out exactly what to do. Let's start. I'm going to start immediately by, I'm going to look for the median from A. The median from A is between 2 points. So it is between point A, and point A in our question is -3, 4, as well as the midpoint of BC. Okay, BC being the side that's opposite it. So let's first find the midpoint of side BC. Okay, I'm going to use my midpoint formula here. I'm going to find the x value. So the x value of my midpoint is the average between the two x values. So my two x values are 6 and 2. I add them together and divide by 2. 6 plus 2 is 8, divided by 2 is 4. We do the exact same thing for the y values. I'm going to do 3 minus 5 because it is a negative y value here. Again, divided by 2. 3 minus 5 is -2, divided by 2 is -1. So the midpoint of BC is located at 4, -1. Now I need to find the median, the equation of the line between my vertex A up here and my midpoint of BC, located right about here. I can go ahead and do that, the equation of the line. So equation of the median. In order to find the equation of the line, we need to find the slope of the line. So I'm going to find the slope using the slope formula. y2 minus y1, so it's going to be -1 minus 4 over 4 minus -3. -1 minus 4 is -5. 4 minus -3 is like 4 plus 3, so that brings me to 7. So the slope of my line is -5 over 7. I then am going to pick one of these 2 points, and my line has to pass through them, so I can use those points, or one of the points, in the equation. I'm going to pick my vertex, because why not? I'm going to find the equation of my line in standard form using the method that we saw in class this semester. -5 over 7 is equal to y minus 4 over x minus -3. Cross multiply. -5 times x plus 3, remember double negative, that'll become a positive, times 7y minus 4. I use my distributive property here. -5 times x is -5x. -5 times +3 is -15. 7 times y is 7y. 7 times -4 is -28. I'm going to go ahead and move everything to the left-hand side to put this in standard form. -5x minus 7y minus 15 plus 28 is equal to 0. -5x minus 7y, and then this becomes plus 13 is equal to 0. And we recall that standard form has to have a leading coefficient that is positive, so I'm going to go ahead and swap those out. This is going to become 5x plus 7y minus 13 is equal to 0. So this is the equation of our first median. 5x plus 7y minus 13 is equal to 0. Okay, that was the equation of this orange median here. Now let's do the exact same thing for this dark green median coming from B. So the median from B, I'm just going to label that, add a little title here. The median from B has to be between point B, which is located at 6, 3, and it needs to be between that and the midpoint of AC. Okay, so we're going to start by finding the midpoint of AC. Okay, just like we did in the previous question, it's going to be the average of the x values. Okay, so I'm going to say -3 plus 2 all divided by 2. -3 plus 2 is -1 over 2. So that's going to be my x value. My y value is the exact same. We take the average between the two. So I have 4 and then -5. Once again, all divided by 2. 4 minus 5 is going to be -1, and that's all over 2. So the midpoint of AC is -1 over 2, -1 over 2. Okay, now we can find the equation of the median. The equation of the median. Okay, the equation of the median, we know first we need to find the slope of our equation because we need a slope and we need a point. So let's find the slope between our vertex and between our midtop point. So our slope is going to be equal to y2, so that'll be -1 over 2 minus 3 over -1 over 2 minus 6. Negative 1 over 2 minus 3. Well, 3 is the same thing as 6 over 2, so this is going to become negative 7 over 2, all divided by negative 13 over 2, because 6 is like 12 over 2. 1 minus 12 is going to be negative 13. I'm just going to rewrite this over here as a much simpler problem. I'm just going to literally write the division sign the way you used to do it in elementary school, because that helps us figuring out how to divide fractions by fractions. Remember, when you're dividing a fraction, it's like multiplying the inverse, so that's what we're going to do. This is going to be now times 2 over negative 13. These 2's will cancel out. This will give us negative 7 over negative 13, or just 7 over 13, because the negatives will cancel out. Okay, so that is our slope. From the slope, we now need to find the actual equation of that line. The equation has this slope and has to pass through one of the 2 points, either the vertex or the midpoint. I'm definitely going to pick the vertex here because these are whole numbers and that's a lot easier to deal with. So to find the equation of the line, I'm going to set my slope, 7 over 13, is equal to 3 minus y over 6 minus x. Let's cross multiply. Okay, I'm going to go ahead and use distributive property to expand. 7 times 6 is 42 minus 7x. 13 times 3 is 39 minus 13y. Let's go ahead and put everything on the left-hand side. Negative 7x plus 13y plus 42 minus 39 is 0. Collect my like terms. Plus 3 is 0. And once again, we want our standard equation of our line to have a leading coefficient that is positive. So I'm going to swap my signs here. 7x minus 13y minus 3 is equal to 0. That is my second equation here. Recall, we are looking for the point of intersection between these 2 medians. So I have now found both equations of the medians, and I can now find the point of intersection either by solving by substitution or by elimination. I'm just gonna point of intersection. I'm looking for the point of intersection between this equation and my previous equation. This is not going to be nice regardless of how we decide to do it. However, I think I'm going to solve by elimination because it tends to be a little bit faster. I'm going to write my equations on top of one another. I'm going to multiply my equations so that I can eliminate x. I'm going to multiply my top equation by 5 and my bottom equation by 7. This is going to get me 35x 13 times 5 minus 65y minus 15 is 0. And 35x plus 49y minus 91 is 0. And we are going to subtract. 35x minus 35x is nothing, it cancels out. Negative 65 minus 49y gives me negative 114y. Negative 15 minus negative 91 is going to give me plus 76 is equal to 0. I can now rearrange and solve for y. Negative 114y is equal to negative 76, so y is equal to 76 over 114. And I can reduce this. I can actually divide the top and the bottom by 38, and this reduces really nicely to 2 over 3. That is the y value of my coordinate, and now I need to find the x value. So recall we plug that number back into one of our equations. I'm going to plug that into my second equation here. So 5x plus 7 times 2 over 3 minus 13 is equal to 0. 5x plus 14 over 3 minus, and I'm just going to change this right away to be 39 over 3 is equal to 0. 5x is then equal to 25 over 3. Okay, 14 minus 39 gave me negative 25, and then when I moved it over it became positive 25. I am then going to clear this fraction by multiplying everything by 3, so that gives me 15x is equal to 25. I divide both sides by 15, and I can simplify this fraction here. 25 over 15 is the same thing as 5 over 3. And we have found our centroid, so I can say therefore centroid is located at 5 over 3, comma, 2 over 3. Now let's talk about the circumcenter of a triangle. The circumcenter is the point of intersection of your 3 right bisectors, okay? I've gone ahead and drawn a triangle here and the 3 right bisectors. Recall that a right bisector passes through the midpoint of each side of your triangle, and it is perpendicular to that side, which means that its slope is the negative reciprocal of the slope of this side here. The circumcenter is also equal distance from each vertex. So I have my circumcenter here, and I can see pretty well it is equal distance from each vertex, and that is why it is useful. Let's look at an example here. 3 benches in a park are located at the vertices of a triangle. On a grid, the triangle has vertices A, negative 3, 4, B, 6, 3, and C, 2, negative 5. A lamp post is to be installed so it is the same distance from each bench. Determine its location. So what we are looking for is the point of intersection of our right bisectors, and we can see that all 3 of them are going to intersect, so we just need to find the point of intersection of 2 of them, and we know the third will follow suit. In order to find the point of intersection, I need to find the equations of my right bisectors. In order to find the equations of my right bisectors, I need my midpoints of each line, and I also need the negative reciprocal slope, once again, of each side of my triangle. I'm going to go ahead and label this A, B, C, and let's get started. First, I'm going to start with side AB, okay? I'm going to look for the right bisector of AB. First things first, let's find the midpoint of side AB. The midpoint of side AB, we're just going to use the midpoint formula once again. X is equal to negative 3 plus 6 divided by 2. Negative 3 plus 6 is 3 over 2. I'm also going to find the y value of the midpoint, 4 plus 3 over 2, which is just 7 over 2. So I can say that my midpoint of side AB is located at 3 over 2, 7 over 2. That's the point that our right bisector needs to pass through. I also need to find the slope of the line AB. I'm going to use my slope formula. M is equal to 3 minus 4 all over 6 minus negative 3. 3 minus 4 is negative 1. 6 minus negative 3 is just 9. So my slope is going to be negative 1 over 9. But recall, we are looking for our negative reciprocal slope. Okay, so the actual slope of the right bisector is going to be the negative reciprocal of negative 1 over 9. Flip that, switch the sign, is 9. So I now have the point my right bisector passes through, as well as the slope of my right bisector, and I can go ahead and find the equation of my line, which I'm going to do so here. I'm going to find it in standard form. So I have slope is 9 is equal to y minus 7 over 2 divided by x minus 3 over 2. I'm going to go ahead and cross multiply. 9 times x minus 3 over 2 is equal to y minus 7 over 2. Go ahead and expand. 9 times x is 9x. 9 times negative 3 is negative 27 over 2. I'm going to move everything to the left-hand side to put this in standard form. 9x minus y minus 27 over 2 plus 7 over 2 is equal to 0. Negative 27 over 2 plus 7 over 2 is negative 20 over 2, which is just 10. And there is the equation of my first right bisector. Okay? That was the right bisector of side AB. So now let's find the equation of the right bisector of AC. Okay, first things first, we had to find the midpoint of side AC. The x value here, again, we're taking the average between the two, so it's going to be negative 3 plus 2 over 2, which is negative 1 over 2. And do the exact same thing. 4 minus 5 over 2 is negative 1 over 2, so my midpoint is at negative 1 over 2, negative 1 over 2. Next, we are going to find the slope of AC. Okay, the slope of AC using the slope formula, m is equal to y2 minus y1 over x2 minus x1. Simplify, negative 5 minus 4 is negative 9. 2 minus negative 3 is 2 plus 3, so that's just 5. So my slope here is negative 9 over 5, but I need my negative reciprocal slope. The negative reciprocal of negative 9 over 5, we flip, switch the sign. Negative reciprocal is going to be 5 over 9. So the slope of my right bisector is 5 over 9. The midpoint is negative 1 over 2, negative 1 over 2. And now we just need to find the equation of a line with this slope and that passes through this point. That is going to be our step number 3. Our equation. Once again, I'm going to do it on standard form. 5 over 9 is equal to negative 1 over 2 minus y, negative 1 over 2 minus x. Go ahead and cross multiply. 5 times negative 1 over 2 minus x is 9 times negative 1 over 2 minus y. Use my distributive property here. This becomes negative 5 over 2 minus 5x is negative 9 over 2 minus 9y. I'm going to rearrange negative 5x plus 9y minus 5 over 2 plus 9 over 2 is equal to 0. Negative 5x plus 9y. Negative 5 over 2 plus 9 over 2 is 4 over 2. 4 over 2 is just 2. And finally, because as standard form we want our leading coefficient to be positive, I'm just going to multiply everything here by negative 1, or switch the signs. 5x minus 9y minus 2 is equal to 0. And this is our second equation that we are dealing with here, our second right bisector. So now I need to find the point of intersection between those two equations. So I have 5x minus 9y minus 2 is 0, and 9x minus y minus 10 is equal to 0. I'm going to multiply my second equation here by 9. And that way I can I can eliminate my y. So this is going to become 81x minus 9y minus 90 is 0. And I can solve by elimination using subtraction because it's the same sign. 5x minus 81x is equal to negative 76x. Negative 9y minus negative 9y cancels out. And negative 2 minus negative 90x is like negative 2 plus 90x. So that's going to be plus 88 is equal to 0. Negative 76x is then equal to negative 88, so x is equal to 88 over 76. And I can reduce this fraction by dividing everything by 4. X is then going to be equal to 22 over 39. That is the x value. I can go ahead and find the y value by plugging in my x value into one of my previous equations. I'm going to pick my second equation here because y is nice on its own. 9 times 22 over 39 minus y minus 10 is 0. Nine times 22 is equal to 198 over 39 minus y minus 10 is 0. Negative y is equal to, I'm just going to move everything over here, negative 198 over 39. And this negative 10 will become a positive, and I'm going to change it to be 390 over 39 just so that I can add these together. Negative y will be equal to negative 198 plus 390, which is 192 over 39. Switch the sign here. Y is equal to negative 192 over 39. And I do not believe that that reduces. So our final solution here, the circumcenter that we were looking for, the circumcenter is located at 22 over 39, negative 192 over 39. And that's that.